Good afternoon, this is Jason Robinson with RGAG. Welcome back to the RGAG YouTube channel. Today's video is about taking the melt temperature. So taking the melt temperature is a very important thing to do in documenting your processes. Yet, it is very difficult to do and very difficult to do scientifically. There's different ways to measure the melt temp. I'm going to go over a few techniques today and some tips and some tricks to maybe be a little bit more consistent with your melt temperature taking and a little bit more accurate. So the reason we have to take the melt temperature because we cannot assume that the barrel temperature set points always correlate to the melt temperature being the exact same temperature as the set points. Occasionally, you can set your melt temps at, let's say, 475, and your melt temp may actually measure at 475 with the pyrometer. But many times, there will be an offset. So, for example, you might set your barrel temperatures at 475, and you may get a reading of 430, 440, or it could be on the higher end. Maybe you have your set points at 475, and you're getting 495, maybe even 500. A little bit of that offset is normal and can be expected on any machine you walk up to. There are some causes that you could identify that could be causing that offset, especially when maybe it didn't used to be that way on that particular machine. In my lab here in Woodstock, I have two machines that are less than a year old, very similar size screw and barrel, and to get the same actual melt temp out of the nozzle, I have to set the barrel temperatures about 30 degrees different from one another. And there's many reasons for that. Some reasons could be just a different geometry of screw, even though both machines have a general purpose screw. General purpose screws from one manufacturer to another are not always identical. They might have slightly different compression ratios, slightly different L over Ds. Another reason that's not a bad reason, just the reason for how the machine functions, it could be the barrel utilization for that mold that's in the machine at that particular time. Could be how the PID loops, so how the controller signals the heaters to turn on and off. Some other things that can impact your melt temp could be the screw surface speed setting, and maybe to a small extent the back pressure setting. So before I get into the techniques of how to take the melt temp, there's a few things we have to keep in mind. First thing is safety. I'm wearing my safety glasses. We are going to be grabbing hot plastic in some fashion, so safety is key there. So safety glasses, I'm going to be using a heat resistant glove for the plastic I'm running. I may try to put the plastic onto some cardboard to further insulate my hand from the hot plastic. The second thing, so safety's first, you don't want to get plastic on your hand. Secondly, the machine needs to be running consistently for a period of time. So this machine behind me has been running for approximately 15 minutes. So this is a 40-ton machine, about a 22 millimeter diameter screw. So 15 to 20 minutes is when we see a machine of this size stabilize as far as melt temp. You don't want to just walk up, make a couple shots, and measure the melt temp. It's going to be colder than it will be later. The bigger the machine, the longer the time that takes. So keep that in mind. Second thing is to have your equipment ready. So I have, like I said, my safety glove here, maybe a piece of cardboard. I have a pyrometer. This is one we keep in our lab toolboxes here. This is my personal one. A little bit better in my opinion, just because the meter has some functions. It'll hold the max temperature for me, so I don't have to stare at it. And then the other difference is the actual probe. This type of probe here is very, very thin. This one's considered a thin probe, but it's a little bit slower responding than this one. So it doesn't really matter which one you use, except for the fact that we recommend you do use a fast response probe. As opposed to a probe that doesn't say it's fast response. That keeps the probe itself from cooling down the plastic. So you want it to react very quickly when the hot plastic hits it. And then any meter, the probe is more important than the meter. And the reason that this is, and we're going to experiment with this little piece of equipment here. That'll be the last one. I'll show you how to use that one right there. Consistency is key. So your technique, the reading you get is heavily dependent on your technique. So what I'm about to show you takes practice. How quickly you purge the machine out, how quickly you grab it with the glove, how quickly you put the probe into the melt, the motion you use when it's in the melt, all those little things that are user dependent can really influence the reading you get. The other thing is always use the same style of probe, whichever probe you use. The meter, probably not as important to use the same one, but it doesn't hurt to use the same one. The other thing, some people like to preheat the probe. With using fast response probes, that's less of a necessity, although it's never a bad idea to preheat the probe if you wish. I would recommend that you always preheat it the same way though. So if you're gonna heat it up with a torch, which would be my least favorite because lots of bad things can happen with a torch, always do it the same. If you're gonna stick the probe into a preheating device, like a thermocouple calibration device to preheat this up, and you can set the exact temperature, that would be good too. If you don't preheat it at all, that's okay too. Just use a fast response probe, and when you document your melt temperature with an unpreheated probe, make sure that you check that melt temp later with an unpreheated probe or a preheated probe, either way. Another way to preheat it would be to stick it onto the barrel of the machine right under the guarding for 3 or 4 minutes to let it preheat. So there's many ways to do it, but my best advice is to be consistent, okay? So we're gonna try this right now. So let's get a close-up of me taking the melt temp, and I'll give you some tips and tricks. Thank you. So I have the machine set up and running. I have my piece of cardboard here. I have my glove, and I have my probe set up and ready. The machine's been running. I've hit the max button so that it will hold the max temperature. So that way, if the temperature goes up and then goes back down, I do not have to worry about whether I saw the temperature or not. So I'm going to try to set that right there so you can see it. So now I'm going to put my glove on, put the machine in semi-auto, and then when the machine finishes its cycle, I will put the machine in auto, back up the carriage, and purge it out and grab it and stick the probe in. So I have my barrel temp set at 440 degrees across the board. So a flat profile, 440. Back the carriage up all the way. I'm going to try to get it to stay on this piece of cardboard. Let's see what happens. Let's pull that out. So now I have my cardboard here, my glove, and my meter fell down, but that's okay. I'm going to stick that in there and keep my probe moving around. Keep kneading the plastic onto the probe. Oops. Try not to remove it like I just did. All right, so I got 378. Okay. 378, my barrel temps are set at 400. I'm not convinced that's totally the right temperature yet, and here's why. This is a very small purge to measure the temperature of. And small purges like this are very difficult to measure because they cool off so quickly. If you're shooting a big machine and the purge that comes out is going to be 2, 3, 4, 10, 15 pounds, this taking melt temp becomes a lot easier. So there are some challenges on small shot sizes like this. So I'm going to try another piece of equipment. Welcome back. So this piece of equipment right here is this is similar to what we use at RGG. It's called a purge puck. So there's a little plastic insulator in there. There's 2 magnets. So this is slightly smaller than our locating ring. So what we're going to do is we're going to stick the probe in here, and the probe goes down into that cup. And then we get an Allen wrench and we tighten it down, and then we stick the this ring in there against the mold and run the nozzle up, and it purges onto the probe. So all the hot plastic coming out is blasting the probe, and we should be able to read the temperature here. And this definitely takes the human error or the human differences out of this. So this provides some consistency. So let's take this temperature with this device and compare it to what we got the other way. The other way we got 376 degrees, I believe. Okay, I'm going to back the barrel up now. I have my probe secured into the puck there. So I'm going to set this in there so the channel points down. Just like so. Close the purge cover gently. Run the barrel back in. So I have the meter set to hold the max temperature just like before. This is a different meter, but it has the same function. And I'm going to purge it out onto the puck. So I got a 379, 380, 381 degrees is what I got with this device. 385 is going up. So 385 was the max. So this device provides consistency. So if you're worried about people doing it at with different techniques and how long it takes them to do it, this is one good way that, now it doesn't move the probe around like I would do it in my hand with the glove and this meter over here, but it does blast the hot plastic right onto the probe. So if this is a fast response probe, it will read that temperature very quickly and very accurately, and it takes the human, the difference is how I can do it. It takes that out of the equation because it's going to be the same technique every time. If you'd like to know more information about where we purchased this, feel free to comment in the sections below, in the comment section below. And I really hope this helps. So measuring your melt temp is very, very important. It's how we prepare the plastic. So if we don't prepare the plastic to the right temperature in the barrel, it's hard to do the rest of our process right and hard to keep it consistent. So we need a consistent and accurate melt temp to the material supplier's specifications. So we have to have a material processing sheet to tell us what the melt temperature range is for that specific resin. And then we need to ensure that it is actually leaving the machine in that inside that temperature range. And we cannot assume that the barrel temperatures are going to achieve the desired melt temp. Like I said earlier, this machine was set at 400 degrees even from rear zone all the way to the nozzle, just a flat profile, and we got 380, 381 was the highest temperature I got. If I did this 2 or 3 times in a row using just a handheld probe like this, if they were within 10 degrees of each other, I would consider that accurate enough. So if you ever get a really weird reading, usually it's going to be too cold, do it again. And if it's drastically different, maybe you messed up the first time. If you get 2, 3 readings in a row and you're within 5, 10 degrees, it's probably really close to the reading you're getting. If you use a device like this, the repeatability goes up, so the technique is more solid. If anyone has any questions or comments, please put those in the comment section below. We really love your feedback, and I look forward to seeing you next time. Have a good day.